Hi, my name is Dan Fox, and I'm a Principal Specialist Solutions Architect in the Serverless organization. Today, I'm going to be speaking to you about a feature that can significantly improve the development experience for serverless application developers. It's called AWS SAM Accelerate. Let's jump right in. A little bit about myself. I've been a software engineer for about 25 years, and I've worked in a variety of environments, including consulting firms, large enterprises, small startups, and boutique agencies. And when I think back on my first day in almost any development job, and I encourage you to think back on your own experiences, one of the very first tasks you have as a developer is to set up your development environment. Most of the time, that looks like setting up the entire stack of services on your desktop so you can run your application locally. As a developer, I would be writing unit tests and integration tests and executing them locally. I would expect testing iterations to be fast and convenient. Local host development has been an industry standard for years, and it's safe to say it's a model that many of our customers are accustomed to. But cloud-native application development is different. Cloud-native applications, by their nature, are composed of multiple remote services. These services cannot be installed locally. They're native to the cloud. So developers who want to continue to write code and execute tests in a local environment have to account for references to external cloud services in their code. Developers who want to continue to perform local unit testing will typically use emulators or mock frameworks in these cases. An emulator is a software component that resembles a remote service and often implements its API. Some examples of emulators include SAM Local, which emulates Amazon API Gateway and AWS Lambda. AWS Step Functions has a local emulator. Amazon DynamoDB has a local emulator, and of course there are others. And the other choice for performing local unit testing is to use mock frameworks. Mock frameworks are software libraries that generate replacement objects for external dependencies like cloud services. There are mock libraries like Moto, LocalStack, and AWS SDK Mock that have been specifically designed for AWS services. And then there are more generalized mocking frameworks like EasyMock, Mockito, JMock, and others. And there are dozens to choose from. Now, while mocks and emulators can provide a speedy localhost experience, they contain inherent limitations. Not all services can be emulated. Cloud services evolve, and emulators can't always achieve feature parity. And finally, IAM security policies and service quotas can't be accurately tested. The result here is that when using mocks and emulators, testing is not as accurate. You may design functionality that works locally, but fails in a CI/CD pipeline, or worse yet, in production. Integration tests are tests that span multiple application services. And when we talk about integration testing in the context of cloud-native applications, we typically refer to tests that are performed in the cloud environment against actual services. In cloud-native application development, the value of integration testing goes up because these types of tests are more accurate and reliable and complete. But there are also limitations to consider here. The most significant limitation is the developer feedback loop, which can be tedious and long. For example, for a typical Lambda function, it can take upwards of 30 seconds to deploy a function before it can be ready to be invoked and tested in its native environment. After invocation, the Lambda service buffers CloudWatch log calls, so it can take as long as 10 seconds to view the log results of your execution. For a developer used to immediate feedback, a 40-second delay between each code change can have a significant impact on your velocity. The unfortunate result here is that developer productivity is diminished. When we talk to customers about their cloud-native development experience, we hear very consistent feedback. Our customers want the speed of unit testing with localhost, combined with the accuracy of integration testing in the cloud. Today, we have an answer for these customers. Introducing SAM Accelerate. As most of you know, SAM is short for the Serverless Application Model. And SAM Accelerate is a suite of developer tools that increases coding velocity and improves testing accuracy for cloud-native application development. It's distributed as part of the SAM CLI. So, let's break it down. What are the specific features of SAM Accelerate? The flagship feature here that I expect customers to be most excited about is SAM Sync. SAM Sync synchronizes local code and configuration files with your cloud infrastructure stack, speeding up your developer iteration cycle. SAM Logs aggregates multiple log resources into a single local stream, and SAM Trace pulls X-ray traces and service graphs into a local stream as well. Let's talk about SAM Sync. Whenever we do a typical build and deploy to the Lambda service, under the hood there may be quite a few steps involved. You may have to download and assemble your dependency libraries. You may compress your deployment package and upload it to ECR or S3. SAM typically creates a change set for you in CloudFormation. Then you execute that change set, which will modify any related services and cause the Lambda service to perform an update and pull the deployment package from storage, decompress it, and deploy it. With SAM Sync, you can bypass many of these steps. SAM Sync is capable of performing code-only incremental deployments for faster cloud updates, reducing feedback cycles from 30 seconds or more to 7 seconds or less. To get to know how to use these features, it's important to understand how each of the flags works. So I'll be covering some of the most important flags in our session today. To show you the various new features of SAM, I'm going to be offering you a demo today of an application called the Maisie app. This is a photograph of my dog Maisie. As you can probably tell, Maisie is a very good girl. Most of the time. Sometimes, Maisie chews my slippers, and on those days, she is definitely very bad. Maisie's friends and family would like to track the status of Maisie's behavior in real time. So, I've created a simple app using Amazon API Gateway and AWS Lambda to publish Maisie's current status. Now let's see how I can use SAM Accelerate to speed up my development of the Maisie app. Okay, here's my very simple app. You can see that there's a Lambda function defined here and an API gateway as an event source for my function and a very simple handler here. Okay, the first new feature I'll show you here is the most basic SAM Sync command. SAM Sync with only the required stackname flag included. This SAM Sync command deploys or updates all infrastructure and code like SAM Deploy. However, unlike the SAM Deploy command, SAM Sync bypasses the AWS CloudFormation change set process, so this command can produce faster deploys. Okay, let's see how this works with my app. Today I feel like Maisie's been a very good dog. And I also realized that my timeout shouldn't be 100 seconds, it's too long, so I change it to 10. Then I type in the SAM Sync command and I synchronize. The yellow text here is a reminder that the sync command should only be used in development environments. I'm going to skip us forward now a little bit. Okay, now my synchronization is complete. I'll do a quick test here, curling out to API Gateway to make sure my changes were implemented. And yes, they are. Maisie is a very good dog. Now, the sync took about 1 minute and 30 seconds, which is slower than I want, but I did do a full code and configuration deployment. Let's see if I can speed up the feedback loop. Now I'm going to introduce you to the SAM sync code flag. This flag instructs SAM to perform a code-only synchronization. Code-only syncs will be your fastest feedback loop, and they can usually be done in just a few seconds. The type of code that can trigger code-only synchronizations include AWS Lambda function code, AWS Lambda layer code, OpenAPI documents for Amazon API Gateway, and Amazon States language templates for AWS step functions. Let's go back to my Maisie app now and see how SAM sync code works with it. Just now, I got back to my office and I found this big mess. And although I can't prove it was Maisie because I didn't see her do it, she can't fool me with those big doughy eyes. I know it was her, and as much as it pains me to do so, I have to change her status to bad. Okay, I'm going to curl my service and make sure that it's up. Yes, it is. Now, I'm going to change the text to Maisie is a bad dog. And I'm going to do my SAM sync, and I'm going to add the code flag to instruct SAM to modify the code only and do a code only deploy. Okay, now the service is updated. I'll curl it, and there are my results. Now, if I wanted to be extra mad at Maisie, I could call her a very bad dog and do a SAM sync with the code flag. And there, the service is updated. Let's do a curl to make sure. There we go. Sadly, Maisie has been a very bad dog. On the bright side, my synchronizations completed in about 7 seconds each. So I feel pretty happy about that. Now let's talk about SAM Sync Watch. By adding the watch option, you instruct the SAM CLI to implement a watch on the files in your project. When you first issue the SAM Sync Watch command, SAM does a full build. Once the build is complete, SAM will monitor your application directories, and it will perform a synchronization with each file modification. And SAM Sync Watch is smart enough that it will perform different kinds of synchronizations depending on the kinds of changes you make. For example, if you make a change to a configuration file like the template file, it will perform a full configuration and code deployment. However, if you make a change to your code only, it will do a code only sync. Okay, let's have a look at how SAM Watch works in my project. The first time through, it will do a full code and configuration deploy here. And I'll skip us forward. Okay, the sync is complete, and now my application is in a watch mode. Let's go ahead and make sure that my service is up. It's returning. Okay, now I'll make a change. And although Maisie's a very bad dog, it's impossible for me to deny her cuteness. I push save, which activates the CLI and performs a sync. Let's send a curl to API Gateway just to make sure my changes went through, and there they are. I'll go ahead and make one more minor change, and as you can probably tell, I'm getting soft on Maisie. And I click save, and you can get a sense that this is a very different feeling developer experience. Let's verify an API Gateway, and there we have it. Now let's imagine I need to make a change to a configuration file. I'm going to reduce the function timeout from 10 seconds to 6 seconds. And then I click Save. We'll flip over to my watch terminal, and you can see that it's already in action, doing a full code and configuration synchronization. If you'd like to limit your synchronization to a specific resource in your application, you may specify a resource ID in your SAM sync command. You might choose to do this because narrowly scoped synchronizations can be performed more quickly. Specify the logical ID from your template, and SAM will perform a sync for that resource only. Now let's talk about the SAM logs command. With the SAM logs command, you can combine log files from multiple sources into a single local flow. And these can be Lambda function logs, they can be API gateway logs, and step functions logs. You can also tail logs locally with a tail flag. And your logs can also include X-ray traces and service graphs if you use the include traces flag. You can also specify a start time and end time to retrieve log events in a specific time frame. Okay, let's add some log statements to my Maisie app. I'll put one here at the beginning, entering function. And I will put one more log statement towards the end here, function complete. And as you can see, the watch is still implemented on my terminal here. So as soon as I press save, I expect, yep, there it goes. The sync is happening and it's complete. Okay, I've changed my screen resolution a little bit. I hope you can still read it. Turned on API gateway logging, and now I'm typing SAM logs, stackname Maisie, -- tail. And I'll switch over to my other terminal, do a curl request to produce some logs against this function. And now they're streaming into my terminal. Those are API gateway logs on top there, and then you can see combined below the Lambda logging. The final feature we'll cover today is SAM traces. SAM traces integrates with the AWS X-ray service to produce traces and service graphs in your local terminal. You can tail X-ray events with a tail flag, and you can fetch specific trace IDs with a trace ID flag. You can also specify start times and end times to retrieve events in a given time frame. Let's go to my app now, where you can see I've added the tracing property and set it to be active for my Lambda function. And I've deployed this version of code, and now I'm typing SAM traces -- tail. Proceed. And then I'm going to curl my endpoint to produce a trace. And when that comes through, I'll flip back over to the other terminal. And there's my trace. And I'm hoping in a few moments my service map will come through. And there it is. So trace and service graph for my X-ray event. Now, I want to close with a demo that shows how these new capabilities can be put together to enable test-driven development in the cloud. Until now, test-driven development was difficult to do in the cloud context. The feedback loop was slow enough to make it impractical. But with these changes, test-driven development is now absolutely feasible. And let's take a look at how test-driven development might look in the context of my Maisie app. How can I stay mad at this dog. She's so cute and she's so sweet. She's probably just misunderstood. I know in my heart of hearts that Maisie is a good dog. And furthermore, that she's going to be a good dog from this day forward. In fact, I'm so confident in my girl that I'm going to write a test in my application that expects her to be good. If you've done test-driven development before, the layout of my IDE might be familiar to you. In the top left panel, I have my test code that creates some expectations. In my top right panel, I have my functional code that fulfills those expectations. In my bottom left panel, I have a terminal that executes my tests. And in my bottom right panel, I have our watcher. Now, as you can see, my first test failed. The service is under the mistaken assumption that Maisie's a bad dog. And of course, we know she's not. So I'll make the necessary change and do a save. And if you look at the bottom right, you'll see the watcher activate and complete. And now all is well again in serverless land. My tests are passing. Maisie's back in good graces. And now you know a little bit more about some of the possibilities created by SAM Accelerate.